Okay, so in this video, we're going to talk about zeros of polynomial functions and multiplicities. So the first thing is zeros. What are they? Zeros for a polynomial function are values that when plugged in, give an answer of 0. Graphically, which is the thing that we're looking at more so, these are the spots where we cross the x-axis. Now, when we talk about multiplicities of 0, this is how many times a particular 0 or a particular value that is a 0 comes up or occurs. Now, we have two scenarios here. One is that if a 0 has an even multiplicity, so that particular 0 value is there twice, it's there 4 times, 8 times, whatever, then the graph will touch and turn on the x-axis at that 0. And I'm going to show you what that looks like here in just a second. Now, if the 0 is an odd multiplicity, meaning it's there once or 3 or 5 times or any other odd amount of times, then it crosses the x-axis at that particular 0. Now, in either one of these scenarios, the higher the multiplicity goes, the flatter the graph will be at that particular 0. So we're going to take a look graphically at what that means. So let's say that we had a 0 at 3, okay? And let's just say that it had a multiplicity of 1, okay? So graphically what that tells us is here at 3, I would have a dot right on the x-axis. Now, because it's a multiplicity of 1, this is a cross spot. Now, for a multiplicity of 1, it's just going to go straight through, okay? Now, it could come downhill depending upon how we're playing connected pieces. I'm just going to show it going this way. Now, if it were to have a multiplicity of 3, okay? So we talked about when it goes higher in multiplicity, it's going to get flatter. Now, this is still a crossing because it's an odd. What's going to happen, it's going to take on kind of this S-curve-ish shape that happens, okay? And then if we look at something even higher, let's say a multiplicity of 5, then it would be kind of an even more exaggerated S-curve going through there. And again, these could come this way and S-curve down through here, okay? I'm just showing one direction. Now, let's talk about that same 0 at 3, but let's say that it had a multiplicity of 2, so it's there twice. So this is now one of those touch turn, okay? So again, graph picture 1, 2, 3. I've got a spot right here, and I'm again going to show this one way it could come from the other. If it's a straight up, just it's there twice, I do a graph shape like this. Again, this could come from underneath. That'll be dictated by what part, how we need to play connected parts and pieces, okay? So it goes up like this. Now, if this had multiplicity of 4, so again, it's still even, so it's still a touch turn. This graph is just going to be a little bit wider as it goes through right there. And again, if we go higher, it's just going to kind of keep getting wider and flatter as it goes through there. Okay, so we've got something that looks kind of like that. Now, let's take a look at kind of the examples that they want us to look at here. So this first one asks us to find all the zeros of x cubed plus 2x squared minus 4x minus 8. Okay, so in order to do this, we are going to set this equation equal to 0. Okay, and we're going to solve this. Okay, so I've written it down here. Now, we've seen problems like this before. We saw it back over in section 1.6. And if you're not familiar or you don't remember that, go back and check out the videos about section 1.6. So this is a factor by grouping. So we're going to partner pair the first two and partner pair the second two. The first two have an x squared in common. I'm going to pull this in a different color. That's x cubed. When I take out the x squared, it's going to leave me an x. And then 2x squared, when I take out the x squared, it's going to leave me a plus 2. Now, looking at the second two, they're both negative, so I'm going to pull the negative. They'll also both divide by 4. So when I look at what that leaves me left over, when I do negative 4, that leaves me an x. When I have negative 8 and I divide out the negative 4, it leaves me a plus 2. Now, with factor by grouping, we do need to have that these two pieces match, and in this case they do. So that is now going to give me, I'll pull my x squared minus 4 for my front pieces, and then my common x plus 2. That happens with that one. And now we're going to set each of those pieces equal to 0. So here I'm going to add 4. In order to get rid of the x squared, I'm going to take a square root. And again, since we brought in the square root, we have to bring in a plus and a minus. The square root of 4 is 2. So I'm going to have positive 2 and negative 2 as solutions. Up here, I'm going to subtract 2. So I've got negative 2. Now, if we're going to talk about the zeros, we have a 0 at 2, and its multiplicity is 1, because it's only here one time out of all the answers that I see. I also have a multiplicity of negative 2, or negative 2 is a 0. Its multiplicity is 2 because it's here twice. Now let's talk about how this would help us with our graph, okay? So we kind of have to tack on stuff. So in behavior-wise, I've got an x cubed as my biggest thing. So that is an odd power, so I know it's going to act like a line. It is positive, so it's going to act like an uphill line. So I've got this end up and this end down, okay? Now, I have 1 over here at negative 2, okay? And going back to our information down here, this multiplicity of 1, this is a cross point, and this one is a touch and turn, okay? So back up here, I've got 1. I've already marked the 1 for negative 2. I'm going to mark the 1 at 2. So now, here's what I know. If this graph, if I'm going to make that continuous connected graph, here's what's going to happen. If it's coming up from here, when it gets this one at negative 2, which we said was a touch and turn, that graph's got to be a touch and turn, so it's just going to be a round hilltop right there. And this is what I was talking about where we let the graph kind of help us out. Now, somehow, this graph is going to have to get itself kind of switched back around and come back up over here. When we get over here to 2, it has a multiplicity of 1, which is a crossover point. Okay? Now, what does this graph look like? I don't know. It may be something very simple. Okay, I'll do a really simple one here in blue. I'm going to move this purple over just a smidgen. Okay. Okay, so blue is kind of a very, very simple graph. Maybe it's something a little more involved. Maybe this thing comes up and over and it does a little bit of this and then it does this. I don't know. So the blue and the red part of this graph, I don't know which one it is. I don't know if it's something in between. I have no clue. But what I do know is the purple parts of the graph. I know this end is down. I know this end is up because of my end behavior from here. I know that this is a touch turn and this is a cross. And because of how the graph is going to play connection, I know that these have to occur this way. I also know that there's nowhere else on the x-axis that it touches because I found all of my spots here. Now, let's take a look at another example where the problem is given to us just a little bit differently, okay? So this one, they have the graph, they have the equation already kind of factored out for us. Now, this is really nice for us to be able to find our zeros and their multiplicity really, really quickly, okay? So we've got negative 4, and then we've got the factor x plus 1/2 squared, and then x minus 5 cubed, okay? So they want us to give the multiplicities of each zero and say whether it crosses or touches and turns at that point, okay? So again, I've written this down. So first off, the way that we're going to find the zeros is we're going to take the piece of the factor and we're going to set it equal to 0. So I'm going to subtract a half. So this is negative 1/2. Now, the reason these are nice, this power right here is its multiplicity. Because basically they're saying this factor happens twice, which means that this value of negative 1 would also occur twice. So it has a multiplicity of 2. So now pull in the other one. I've got this x minus 5 equals 0. So I'm going to add 5. I've got x equals 5. And this one has a multiplicity of 3. Now, again, with the multiplicity of 2, this is a touch and turn. With a multiplicity of 3, this is a cross. Now, we also know, though, that this is going to be one of those kind of lingering S-curvy looking ones. Now, if we were going to start to try and play graph pieces with this or finding, graph ideas, and we're going to start with end behavior because we always start with an end behavior, okay? Here's what we would have. If I took all out, so if I had negative 4, x plus a half, x plus a half, x minus 5, x minus 5, x minus 5. And I'm not saying we're multiplying this out, but here's the concept. If I pulled these two pieces together, I would get x squared with a bunch of stuff back behind it. And if I took x squared with this next piece, and I multiplied those together, I would get an x cubed with a bunch of stuff back behind it. And if I took this x plus 1/2, along with that x cubed chunk that I had, I would get an x to the 4th with a bunch of stuff back behind it. And then if I took this piece and I multiplied it with that x to the 4th, I would have an x to the 5th with a bunch of stuff back behind it. Then bringing in that negative 4, I would have negative 4 x to the 5th with a bunch of stuff back behind it. So not as easy for us to get our end behavior as the other one, but we can still discover it. So with this one being an x to the 5th, x to the 5th still says that's an odd power, so it's still going to act like a line. It is just going to be that it is, and it's negative out front, so it's going to be down a hill. So this is now going to be up on this end, down on this end. And now we're going to bring back our zeros. So I've got a spot right here at negative 1/2. And I have another one over here at 5. Okay, so now let's talk about it. If these are all going to play connect, I've got to come down from here. When I get over here to this negative 1/2, we said that that was a touch and turn. So that must go this way. Okay, somehow this graph has got to get switched. There's a little hump, bump, lump thing, something over here to get over here. Now, over at 5 is a multiplicity of 3. That means that this thing has to do some little kind of S-curvy thing down through here. Okay, I'm going to move this down arrow over just a little bit. The purple stuff is what I know. Simple graph connection. Okay, move this one over just a bit, still maintaining that it's up. Simple graph connection. Straight connect, again, keeping it nice and smooth. Okay, humpy, no sharp corners, kind of keeping this as nice and smooth as I can. There we go. Now, little more involved one. Okay, and again, I don't know which one it is. It may be something that's a mixture of the two, not real sure. But again, the dark purple parts are the things that I know. And this is all about building the picture. We may never know the exact picture, but we can definitely put in parts and pieces that we do know.